Hello, this is the mini injection desktop machine from HP Plastic Machina. I introduced to you the parts and the systems of the machine. This machine consists of a HMI controller panel, an injection screw system, cylinder and heating elements that driven by a servo motor, the clamping system you see here that driven by a ball screw and a step motor system, also the mold, the standard parts of the mold consisting of plates, bushings, pins, ejector pins, ejector plates, also the cavity of the mold, the insert, okay, let's see how you can run the machine. After turning on with this key, you can access to the HMI panels, different HMI panels that I show you here, the home menu that you can see the settings of the injection process, temperature setting, number of cycles, number of products, a key for home sensor, a key for doing the process all automatically, reset button, heating button, controls for moving clamp forward and backward, controls for moving a screw forward and backward. The next menu, the next tab is the manual tab. You can access to the heater parameters, heater controller, PID parameters, set values, sensor type and other values. You can manually move clamp and screw forward and backward. In this step, the setting menu, the timer menu, the menu for monitoring the commands of the control system, and the error tab. Let's go back to the home menu. After we set the temperature, we wait for the temperature raises to the set value to our desired value, and we can easily input injection parameters like a screw track, which means how many turns the injection screw for injecting your mold, a screw retract for when injection process complete is a part of a round or so many rounds, a screw will be retract backward, the speed of the tract and the speed of the retract. You can easily set the parameters with the keypad, and also distance for closing the clamp, distance for home sensor, time for cooling, and other parameters that we show you in the process. Okay, for running the test, first of all you need to go back the clamp to the home position. I show you. The clamp will move backward until it reaches the proximity sensor. Here you see. I'll explain you later in this video how to set your proximity sensor and set the distance for the clamping system. After going the clamp panel to the home position, we need to empty the injection cylinder from the old material and put some new materials by clicking screw forward manually. The remaining material will be ejected from the nozzle system. We continue this until all of the remaining granules and materials in the cylinder comes out. Then we clean the material with some tool. Okay. For starting the injection procedure, we turn on the fan for cooling system, put some granules in the cylinder, after setting the injection parameters here, we must set the screw tracked number of rounds that injection screw goes forward to inject the material. For example, here we set 6.5 rounds. And also we must set the speed of the screw here. For example, here we set the 20 rounds per second for the screw. A screw retract parameter 0.1 is enough, and a screw retract speed 10 rounds per second is enough. And also we must set the cooling time. That's an important parameter for your injection process. You can easily set in the units of milliseconds. For example, this unit means 35 seconds. After that, you need to set the distance for your clamp that goes a way to clamp the both sides of the mold together. For doing this, for setting this, when your moving clamp is at home position, measure the distance between the insert and the nozzle system plate. You see here the distance is something about 60 millimeters. We must set this distance a unit or 2 units upper than something we measures. For example, the distance were 60 millimeters there, we put here 61 millimeters to ensure that when the clamp and the nozzle plate comes together, there are in the pressure. Okay, and also we can set the speed of clamping. You see here, and also we can set the time for take out the molded part. This value means when the injection process completes and the clamp goes backward, how many seconds it will take that you can eject the molded part and starts the next round of the injecting system. Okay, we set the parameters. Let's go home again. Let's go home again and start the automatic button to inject the parts. Before you start the automatic procedure, you need to empty the cooled material in the nozzle out, and after that you start the automatic process. let the cold material ejects. Clean with some tool. Okay, take out the colded materials and then go on with the automatic button. The clamp moves forward to reach the cavity plate and the nozzle plate together with a little press. After that, injection part goes up. Cooling time is going on, and after the cooling time finishes, the clamp will move backward. You see the mold is created. The ejector pins are activating. And then goes for the next step. You see here the next molded part. The clamp goes backward, ejectors are activating, and take out the part easily. With this procedure, you can continuously produce the molded parts, how many you need, and you also be careful about the materials, the granules on the top of the cylinder. Okay, in the next part of the video, I will show you how to change your molds and inserts, and also how to set your proximity home position sensor. Okay, in this part we want to show you how you can change your mold, or precisely your insert. Different types of inserts or molds or mold cavities can be produced for you in this shape. Mold cavity, ejector pins, springs, bushing screws, ejector plate, supporting plate. Let's see how you can change the insert. You need to untie these 4 screws in the insert. Here, see the screws that goes here. Untie them with the proper socket wrench. After unlocking the 4 screws, you can easily take out the insert in this way. Go the clamp backward, take out the insert and replace the new insert with the marks up. You see here's a mark in the insert, and here's another mark on the upper side of the support plate. Put the insert through the place and lock the screws. As you see here, this insert mold is a 2 cavity mold designed for ISO samples in different standards, ASTM and ISO. Let's see how this mold will be injected. Take out the cooled material in the nozzle. Check the distance for clamping with a ruler. Go to home position. You see the distance is the same as the other mold we tested earlier. Okay, ready for the test. When you press the automatic button, clamps will goes near to secure and close the both placed together and put into the pressure. When 2 plates meet each other, the injection process starts. Now it's time for the cooling procedure. The machine will count down the time you set here for the cooling time, and after reaching that time the clamp plate will go backward and you can take out the molded part. You see clamps open and it goes back until the pins for the ejector plates will be activated. You see here the springs goes down. You see here the ejectors. You can see this. Okay. And it's the molded part. Let's trim this. Cut the screw line. Here is ISO test samples. Another part, injecting continuously. Okay, we want to change the insert mold to going to the third mold, and we need to change the inserts. Please be careful that when you want to change the inserts, the springs of the ejector plate don't be in the pushed position. You see here, always you must have a little space between the pins behind the ejector plate when you want to change the clamp. It is a safety precaution for you. I repeat it, pay attention please. When you want to change the inserts, there must always be a little space between the ejector plate and the pin behind the ejector plate, in order to the springs be in the release position, be in the free position. And also take care the ejector pins doesn't came out from the cavity. The ejector plate, the ejector system must be in the free position in order to change the insert. Now we want to install this mold dumbbell based on the standard ISO 527 type 5A. A little dumbbell. Note the marks for upper side. Let's see the setting for the proxy home sensor. First of all, you need to open the steel tray with this screw. Okay, after opening the stainless steel tray, you can reach the proximity sensor here, installed on a base, a sheet metal base. You see here you need two wrenches with number 17 to lose the nuts upside and downside of the proxy. As you see in the field, after losing the nuts of the proxy, you can easily change its position downward, backward, or forward. In order to the light of the proxy will be on, and you must set the proxy underneath the moving plate, this plate that goes through 4 graphite bushings. When the lights turns on and the sensor is directly behind the directly under the moving plate, you can tighten the knots and the home position has been set. The position for home must be set in order that the pins behind the ejector plates don't push the ejector plate, and the springs will be in the release position, in the free of tracting position. The clamp plate, moving plate, is up to the proxy sensor. The light is on, and you see here the distance between the ejector plate and the pins behind it. And also note that a support plate for the pins is behind the moving plate. Set your home position in order to, there was always been a distance between the supporting plate and moving plate. We installed the third insert, third mold, the dumbbell for ISO 527 type 5A. First take out the cooled material. Take out the cooled remaining material in the screw in the nozzle system. Go back to the home position and start the automatic procedure. In this part of the video, we want to show you the setting in the setting menu for the calibration of the speed and distances in a screw or in clamp. When you enter the setting menu, first tab is timers for setting the number of parts you produce in each cycle. You can easily change them. The next tab, screw number 1, is the pulses per revolution of the screw for the calibration of the speed of the ball screw for injection screw, and other parameters: screw manual speed, screw manual distance in units of round, screw deceleration, screw track distance. You can easily change them, but be careful that the first one, the pulse per revolution, is calibrated for you. We recommend that you do not change this parameter. Next tab is clamp. clamp 1. Also number 1 in this tab is pulse per revolution of the clamp. Also we calibrated it for you, and the other parameters. In the tab clamp 2, these parameters are for inserting more pressure in the clamping process, but you don't need for your molds. We recommend that, we suggest that these parameters remain 0.